Okay, we've looked at finding limits from a table. We've looked at finding limits with a graph, but what about just an equation? So limits, we end up with weird things happening when we have asymptotes, when we have holes in the graph, when we have piecewise functions, those types of things. What kind of function is this? Well, x squared, that's a quadratic, that's a parabola. It's not going to have any weird spots. So if I try to plug in 2, I'm actually going to find my y value. So I would do 3 times 2 squared minus 4 times 2 plus 1. So 4, 12 minus 8 plus 1 is 5. What about here? This does have a vertical asymptote, but let's see what happens if I plug in 3. So 5 times 3 plus 2 over 2 times 3 minus 3. So I get 17 over 3. Well, that's a good number. It's good. X squared minus 9 over x minus 3. All right, I'm going to plug in 2. Four minus 9, that's negative 5 over negative 1. That's 5. Now, there is a spot that would have something weird happening. What number would that be? It would have been x equals 3. But x equals 2 is fine. Let's look at this next one. What x value would be a bad one? Well, looking in the denominator, x plus 1. If x was negative 1, I'd have something weird happening. But we're looking as x approaches 2. That's going to be fine. Okay, so square root of 2 plus 2. So the square root of 4 minus 1 over 3. That's 2 minus 1. That's 1/3. Now let's look at a piecewise function. This means this is the rule I'm following for all the x's less than 3. This is the left side. But if x is greater than 3, I'm following this rule. That's the right side. So when we're finding the limit, and it's x approaches 3 with a minus sign, that means I'm looking only at the left side as it approaches from the left. That means I'm going to plug in to the left portion when x is less than 3, and it's pointing to the left. So I'm going to plug in 3 into the left part, or piece. So 9 minus 4, that's 5. What about coming from the right? So 3 from the positive side. That means I'm coming in from this side. So 2 times 3 minus 7, that's a negative 1. So this means as this graph approaches 3, the left side's going to positive 5, the right side's going to negative 1. So the limit as x approaches 3 overall would be does not exist because the left side does not match the right side. Let's try another piecewise. So this is the rule when x is less than negative 2. This is the rule when x is greater than negative 2. So there's the right side. So as x approaches negative 2, the minus sign means I'm coming from the left. So I'm following this rule. So 2 times negative 2 squared plus 3 times negative 2. So that's 4 times 2 is 8. Minus 6 is 2. As x approaches negative 2 from the right, so we're going to follow this rule. So negative 1/2 times 2 would be a positive 1, plus 1 is 2. So on this one, the left side and the right side are approaching the same value, so the limit as x approaches negative 2 is 2. Now let's see what happens when direct substitution doesn't work. So let's look at this one. If I tried plugging in, I would have negative 3 squared plus 4 times negative 3 plus 3. then negative 3 squared plus 2 times negative 3 minus 3. So I've got 9, negative 12 plus 3, that's 0. 9 minus 6 minus 3, that's 0. I've got 0 over 0. That's bad, bad, bad. That's not 0. It's not undefined. It's indeterminate. I don't know what it is. So let's think about what's happening. So if I actually looked at this graph, at negative 3, I've got a hole. Okay, so rational functions can have vertical asymptotes, they can have holes, they can have horizontal asymptotes, all these things. So what we can do is we can actually factor. So what I'm going to do is I'm going to take the limit as x approaches negative 3. I'm going to factor the numerator and factor the denominator. So I get x plus 3 over x plus 1 and x plus 3 over x times x minus 1. In this case, the x plus 3's can cancel out because I know I have a hole there. This leaves me x plus 1 over x minus 1. So now I'm taking the limit as x approaches negative 3 of x plus 1 over x minus 1, and I'm going to plug in negative 3. So negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. I get a 1/2, which is the y value of the hole. It's what the graph is approaching from the left and from the right. Now, if I had just looked at the graph, I could have guessed 1/2, but I wouldn't have known for sure. So by doing this simplifying, by factoring and simplifying, I can actually find the limit. So let's look at the next one. If I plugged in 2, I'd have 2 in the denominator, 0 in the denominator and 0 in the top. So that's not going to work. So let's factor. So I have x minus 2 in the numerator and x minus 2 in the bottom. That means there's a hole in the graph. So what I can do is simplify the function by dividing those out, and now I have the limit of x plus 2. Well, I can plug in 2 and get that the graph is approaching 4. Let's see. So I'm going to factor this and see if anything's interesting. So x squared minus 5x plus 4, that's going to be x minus 4 and x minus 1. X squared minus 2x minus 8, that's x minus 4, x plus 2. These would cancel out. That means there's a hole at 4. So that point does not exist on the graph, but a limit does. I can plug in 4 for my x's. So 4 minus 1 over 4 plus 2. I get 3 over 6, or 1/2. Try the next one. Press pause if you want. Okay, so if I factor, I would have x plus 7, x minus 1, then x plus 1, x minus 1. Now I'm left with the limit as x approaches 1 of x plus 7 over x plus 1. Plug in 1. 8 over 2. The limit is approaching 4.